This question asks us to find and identify the type of critical points for the function f of xy is equal to 4x minus 3x cubed minus 2x times y squared. Okay, so what we're going to do first is just find those critical points. So let's start with that. So we're going to find our f sub x first. So that would be a 4, and then we have minus 9x squared, and then minus a 2y squared. Okay, so that's our f sub x. And then let's find f sub y. That's going to be, when we differentiate there, we're going to get a negative 4x times y, right? So that's pretty simple, right? So what we want now is for both of these to be 0, both of these equations to equal 0 at the same time, okay? So looking at the equation on the right side, our x could equal 0 or our y could equal 0, right? So if x equals 0, so let's try that one first. So if x equals 0, then what do we have on the left side? We have that 4 minus 9 times 0 squared minus 2y squared is equal to 0. So this term goes away completely, and we get that 4 is equal to 2y squared. If you move it over there, divide by 2, and we get that y squared is equal to a 2. So that means that our y could equal y equals plus or minus radical 2 when you square root both sides, right? So if x is equal to 0, then our y could be either of these values. Now let's try, we'll try the y being equal to 0. So if y is equal to 0, then we could have, what does this equation here turn into? So then we'll have 4 minus 9x squared minus 0 squared, if we're making our y be 0. Right, so that term goes away, and we get 4 is equal to 9x squared. Okay, and I'll just continue it going to the side here. So we get that x squared is equal to 4 over 9, right? And then x is then plus or minus 2 over 3 after you square root. So this is another pairing of points here. Okay, so these ones go together, these top ones go together, and these bottom ones go together. Okay, so I'll write our critical points on the next slide. So what we had was if x equals 0, then our y could equal plus or minus radical 2. And then if y was equal to 0, then x could equal, a plus or minus 2 over 3. Okay, so another way to write this, our actual points are 0, comma, we'll write the positive radical 2, or 0, comma, negative radical 2. So there are 2 points already from there. And then we have a plus 2 over 3, comma, 0, or a negative 2 over 3, comma, 0, right? Okay, so we actually see a total of 4 critical points. Okay, so this is the first part. We found our critical points, and now we have to analyze what's going on at each of them. Okay, so what we're going to do is apply the second derivative test, and to do that, we have to find the equation for the discriminant. So that's going to be fxx times fyy minus fxy squared. Okay, so what we have to do is find all of these second derivatives, right? So the first derivative, just a refresher, so one of the first derivatives, well, I'll start this on the next slide so we have enough room, okay? Okay, so our first derivatives were f sub x is equal to 4 minus 9x squared minus 2y squared, okay? And then f sub y was equal to a negative 4xy, okay? All right, so if we do fxx, that just means we're taking the derivative of this guy with respect to x. So that would just give us a negative 18x, okay? How about if we take fyy, we're going to take the y derivative of this f sub y. So that would be equal to negative 4x, okay? Now let's take fxy. So that would be taking our the y derivative of this first one here. So if we take the y derivative, we get negative 4y, okay? And then what if we take the fyx? That's going to be the x derivative of this guy here, okay, which is a negative 4y. So see how these two here, those are equal, and that, again, that's a reminder of Clairaut's theorem, saying that his theory of the equality of mixed partials, right? So these are both mixed partials there, okay? So anyways, so those are equal, and according to our discriminant formula, we're just going to plug all of these values in. Okay, all of these expressions here. So what we're going to end up getting is that we have fxx, so that would be negative 18x, okay, times fyy, so that's a negative 4x there, minus a negative 4y squared. So you can plug in either one of these, right? They're the same thing, okay? So then we get that d of xy, that is, right? So this is open to variables right now. So we're going to get 18 times 4, so that's a 72. And then we have x squared. And then we have a minus 16y squared, okay? And if we were to plug that in, if we were to plug in a and b instead, some other points, then we get 72 times a squared minus 16 times b squared, okay? So this is the formula for a discriminant, and that's basically what we're going to use in order to determine what kind of points or what type of critical points our 4 critical points that we found are, okay? All right, so let's write that at the top here. So we have d is equal to 72a squared minus 16b squared, also known as 72x squared minus 16y squared, whichever works for you. Okay, so let's make our chart. What we're going to do is write our a, b coordinate there, and then we're going to have d, whether it's positive or negative, okay, the sign of d, and then we have the sign of fxx, whether it's positive or negative, and then we have the type of critical point finally. That was a really weird Y. Okay, type. There we go. Okay, so we have our chart. All right, let me fill in some of these values here, and let's get started. So A, B, I'm just going to list them on the side here. So our first point could be 0, positive, radical 2. Our next point is going to be 0, negative, radical 2. The next point could be 2 over 3, 0. And our last point is going to be a negative 2 over 3, comma 0. Okay, so for the first one, if we plug in 72 times 0 squared minus 16 times radical 2 squared, that is this first term is 0, so that's definitely going to be less than 0, right? So that's going to be a negative value. So that means automatically we can skip over this column there. This is going to be a saddle point. Saddle point, okay? So saddle point, that's 0 and then positive radical 2. Okay, let's try the next one. So now we have a 72 times 0 squared minus 16 times negative radical 2 squared. And this one as well is going to be a negative value because we have 0 minus some positive number. So that also will be negative, so we can pass over that column and say it as well is a saddle point. Saddle point. Okay? All right, so those are both saddle points. We determined those. And now for this next one, so let's try that guy out. So we have 72 times 2 over 3 squared minus 16 times 0 squared. So that's going to be positive, right? So we have a positive value here. So now that means we have to try out what is our fxx. So just as a reminder, our fxx was a negative 18x, okay? So negative 18 times x, what was x? That's a 2 over 3. So that's going to be a negative value for sure, right? So we have a positive discriminant. So overall it's positive. So that means fxx and fyy have to be the same sign. And since fxx is negative, that means fyy has to be negative as well. So that means it's concave down in both directions, which means we have to be located at a local maximum. Okay? All right, now let's look at this last point. Let's see what we get. So 72 times negative 2 over 3 squared minus 16 times 0 squared. That again is going to be a positive value, right? Because we have something squared minus 0. Okay, and then so that means we have to figure out what is our fxx. So that would be negative 18 again times x, which is now a negative 2 over 3, which the negatives cancel to make a positive number. So we have a positive here. So that means it's concave up in both directions, which means we have to be located at a local minimum. Okay? So that's basically it. That's the whole synopsis there. I'll just write our summary on the next slide. So our critical points, again, we have 0, positive radical 2 and 0, negative radical 2. These are both saddle points. Okay, so we found those to be saddle points. So they're basically from that point, from where we are, it's concave up in one direction but concave down in the other. Okay, and then let's try, we found 2 over 3, 0 to be a hold on, let me write here, local maximum. Okay, and then we found the other point, negative 2 over 3, comma 0, to be a local minimum. All right, and that wraps it up for that problem. Now on to the next.